Okay. Shall I start?
Yes.
Yes, but
Okay. Simple question. Can ultrasat see prompt GRB emission? Uh, now, I think that it could if 10 to the minus 7 of the of a bright GRB happened to find its way into near UV photons, then you could. Yes. Um, Now, in the widely held GRB model, there's a fireball. It's moving at a Lorentz factor of at least 100. Probably most people would say 200 or 300, and therefore, and we know that the observed peak is 200, between 200 and 300 keV, which means that in the frame of the fireball, it's pretty soft emission. The problem is it gets blue shifted back up to 200 or 300 keV. There isn't much that you're going to see. Put in a Rayleigh Jeans thermal spectrum or whatever you want. You're not going to get much in the UV. But there's an alternative model which I've been pushing for I don't know 20 years or so. I didn't call it champagne cork, but that's only since Asaf Be'er, who Mrs. Ireland apparently called it a cork. Anyway, the idea is that since there's a host star and the GRB has to basically explode out of the host star, there's always going to be a baryonic cork just ahead of the fireball, and if the fireball has hard MEV photons, which would you expect from basic, well, you'd expect it under certain assumptions. If the Lorentz factor of the quark reaches 100, well, then in the frame of the quark, the photons are only 15 keV, let's say. And then when you blue shift it back into the frame of the observer, you get, well, you could get, if you're looking at zero opening angle, you get back your 3 MeV. But if you choose the right theta, if you choose the right viewing angle off to the side, off the direction of the motion of the fireball and cork, then you can move it down about an order of magnitude, or you could pick any theta you want and move it down further. Now, if you're going to pick theta wide enough to get it down to the near UV, you still won't have enough for ultrasat to see. But and let me just show there are lots of simulations of a fireball popping out of a host star, and you get this little dense shell ahead of the fireball, and that's the cork, I guess. And well, never mind. Here's another picture which kind of came out nice, where you see a dense shell in front of a less dense bottle of champagne, I guess. Okay, now I asked the following question: what about the heating of the cork? I was talking about MEV photons scattering off the back end of the cork, but there's going to be Compton-Rehor, which is actually going to heat the baryons in the cork, and the temperature you estimate depends a lot on the exact radius and intensity and possibly the number of baryons in the cork. But it gets, according to detailed calculations, something more than half the total energy goes into Compton heating, and so you're getting a lot of energy, but the temperature in the frame of the in the frame of the cork is maybe a fraction of a keV as it was before. But now, now let's assume that you're looking at it at a very large angle, and you're seeing you're at a large enough angle that you're seeing photons that were moving backwards, that were basically backscattered in the frame of the cork back towards the black hole. And you assume that the angle is large enough and that the Amati relation based on viewing angle holds down to 5 eV, then because the energy of the photons in the frame of the fireball was just 1 eV, and combine that with the crippled blue shift because you're at large angle, then the Amati relation predicts that you'll get 5 eV over 1 keV squared of the total, which is actually more than 10 to the minus 5 of the gamma ray burst energy. So maybe in this model, the UV emission is detectable by ultrasat. Note that the UV emission, which is thermal emission from the cork, may also be accompanied by scattered primary photons, which at large angle will appear as an X-ray flash. We have seen X-ray flashes, so we know that's plausible. And we might not always see the X-ray flash because X-ray flashes cannot be seen necessarily all the way out to cosmological distances. But ultrasat is designed to provide better reach. So maybe, I'm not sure about this, but maybe it can discover more GRBs than GRB detectors. Okay, that's the idea. Thank you.